you now have an open source model that you can download, put on your laptop. You can even run it really on your laptop. Okay, it has to be a bit of a beefier laptop, but you can have GPT-4 level performance on your laptop, which is unbelievable. I don't think many people expected that.
You know, I work full-time as a doctor pretty much, and it's amazing. You know, I'm not an expert coder. I could get Llama running on my laptop in 1.5 day.
Yeah, that's...
You know, I'm not even... It's really amazing, the kind of power we have in our hands now.
Exactly.
And it really is the question, what do you do with this power? And especially for us, how do we apply it to healthcare in a meaningful way? What they were quite clear about is they did not want to focus on the high risk stuff. So nothing about like diagnosis, risk prediction, all this stuff. They want a virtual back office in the hospital. Okay,
that makes sense. Yeah,
and we always talk about that's the first thing you should go for, just administrative tasks. Welcome back to Dev and Doc. It's been a while since our last conversation, but today we're going to have a nice chat. We've had big developments lately. We've had Llama3. Yeah. Big news. And also I wanted to delve a bit into the paper of Hippocratic AI, the new kind of safety-focused healthcare large language model that everyone's talking about.
Yeah, I think there is a lot to talk about. Llama3 was not a surprise. I think Meta was talking about Llama3 for over 6 months now, I think. Yeah. And everyone expected it, but I don't think that many people expect it to be this good.
No?
It was surprising for sure, because it is like the biggest model they have published. They published 2 versions of the model. So an 8 billion parameter model and a 70 billion parameter. What is interesting is that the 70 billion is nearly on the level of GPT-4.
That is crazy. That is crazy.
Which is like, you now have an open source model that you can download, put on your laptop. You can even run it really on your laptop. Okay, it has to be a bit of a beefier laptop, but you can have GPT-4 level performance on your laptop, which is unbelievable. I don't think many people expected that.
Have you had to play around on it?
Yes, a lot in fact. I think I was mostly using the smaller one because
the 8B.
Yeah, the 8B.
Yeah. I was trying, right? I got it, to be fair, look, I've been very busy with clinical work. Yeah. I got it running on my MacBook.
Perfect.
The 8B. And I typed in, I basically said, oh, can you tell me a bit about heart failure or something like that?
Yeah.
And then I was waiting for it to generate the tokens. And I waited about 2 hours and still no output. So I just kind of I just stopped it and I just said, can you say R? And it said R after like 10 minutes. So the token generation rate for me was like 10 minutes, at least one word.
Okay, but for that, if you are running it on a MacBook, I think you need to use a couple of, you have an optimized library used by Apple. That is basically, you have those model optimized for MacBooks that are using the capabilities of the M1, M2, M3 models, CPUs on MacBooks, and then it can be really fast.
Oh, I see. So the one I was using probably wasn't optimized for MacBooks.
If you just use the normal out-of-the-box Llama, it will not be the best.
Okay.
Or I mean, it will not be able to use the GPU or the CPU capabilities.
So what was your experience? What did you use it?
So I basically played around just randomly. I was just thinking like, okay, man, it cannot be that good. That was like my initial thought is like, it cannot be that good. Yeah, exactly. Because most of the other models are still like underperforming a bit, and the moment you try to use them a bit more for something more complicated, they fail. Yeah. But this one was awesome. Okay. This one was like, I could basically almost converse in the same way I've been doing with GPT-4.
Why don't you give me an example of what you tried to do with it?
Yeah, I usually have that one coding question I ask like the models, which is a small function they need to write, but they have to consider a lot of edge cases and whatever. So it's like a decently complicated function. And usually when I give these to the smaller models, they just output something that makes no sense. Okay. And Llama solved it like perfect.
This was the 8B as well.
Yeah, this was the 8B
That's crazy.
model. Yeah. that is like, it is unbelievable that now open source and closed source are very close to each other.
Yeah, no, that's what I was saying. Like, you know, I work full time as a doctor pretty much, and it's amazing. Like, you know, I'm not an expert coder. I could get Llama running on my laptop in 1.5 day.
Yeah, that's,
you know, I'm not even. It's really amazing the kind of power we have in our hands now.
Exactly.
And it really is the question: what do you do with this power? And especially for us, how do we apply it to healthcare in a meaningful way?
Yeah, I think there is a couple of benefits that these brings you. I think the first thing is the obvious part you are considering is like, first of all, GPT-4 is closed source and it is behind an API and you are exposing your data to a third party and all of that. This one means like I can really buy a gaming PC, bring it into the hospital and have it running. Don't do that. Don't buy gaming PCs and put them into hospitals. But I'm just saying like what is possible. You cannot believe that you just need one GPU, plug it into the hospital, and I can now do discharge summaries.
Yeah, and as chips get better, I imagine eventually we might have an LLM running on our phones.
Yeah, you have it. It's not we might have, like it was done. You have this 8B running on an iPhone. It is not the best.
Yes.
It takes a bit of time, but at least like we already can do that. It is extremely quantized and the model is minimized basically because you cannot still put a whatever 20 gigabyte model on a phone and have it run smoothly. But the options we are getting with these are enormous. And there is in fact one very interesting platform. I just recently started using it more extensively. It's called Grok. Have you heard about Grok?
What do you mean, Elon Musk's?
No, Grok, they do all LPUs. They are basically like a different type of a processing unit on which you can run your models. So it's like linear processing units, and you can run your Llama model on this LPU instead of running it on
So it's computer processors designed specifically for transformer models?
Let's say yes. They were designed, I think, even before transformers, but they just perfectly aligned for the use case and they could work extremely well. And the thing is that running the 70 billion Llama model on these gets you something like 300 tokens a second.
Wow, okay.
Which is like instant answers.
That's incredible.
Like, if you have ever used like GPT-4 and all of that, it is much slower. Like GPT-4 is currently really at like maybe 5 tokens per second or something. I don't know.
Imagining in the future, you can just either buy or get access to one of these LPU processors, get a private kind of Llama model, and run it inside your organization.
Easy. And have it really be extremely fast. It doesn't have to be the LPU. It can really be whatever other architecture or I don't know, the new version of NVIDIA or something. But I think what these guys have done differently, this Grok platform, is that they have focused on inference over training. So I don't know,
Can you elaborate on that?
So inference is the part, once the model is completely trained, now I use it to generate text, to answer my questions, to predict some output, to whatever is needed. Training is training.
So it's streamlined for running the model from day-to-day usage, basically. Not to change the model or retrain or fine-tune, but just to run it.
Yeah, I don't know. I don't think they have done a lot of training, or I don't know how good is it for training, but I know that for the inference part, it is a million times better. Not a million. A lot better than GPUs. And they are really focused on that and are making it cheap and fast, which I think is awesome.
I feel like this is going to open up a whole avenue as well to enable researchers to explore more of these capabilities using, research data and private data. I think it's easy to get ethics that way and actually explore the capacity and capabilities of LLMs in healthcare.
No, exactly. And just to prove that, there was a model published maybe last week. It is called like BioLLM, Llama3. So it is something that is fine-tuned for medical use cases.
Yes.
When I say use cases, I really mean question answering. So more like specific, smaller use cases, not really clinical. But this model was, so it is again two versions, the 8 and 70 billion, and it is outperforming GPT-4 and MedPalm 2 on medical use cases, on like USMLE and similar.
I'm surprised, because I was going to say, it's not surprised it's outperforming a generalist model because you're using higher quality data, stuff we talk about in this podcast a lot on healthcare data. So of course it's going to be better for answering a USMLE exam or a medical exam. Surprised it's outperforming MedPalm 2 as well.
Exactly, but that just proves how good Llama is.
Wow.
Because MedPalm 2 was made on Palm 2. So that model is already like a bit older, but it is 10 times bigger, maybe not 10. I think it's a 500 billion parameter model. So it's like 7 times bigger than Llama. And Llama is still outperforming it. So Llama is extremely good. And I think the way they've achieved this is most likely the size of the data set and the quality of the data set. Because that's what we were talking about constantly, like that is the important part.
And you know, I was reading an article the other day, apparently because there's a finite amount of text on the internet, I know that to train GPT-4, apparently they got transcripts from YouTube videos as well to help boost. But actually that probably isn't amazing data, right? Transcripts to videos probably is questionable quality.
Depends which YouTube channel. If they trained on Dev and Doc, then I'm sure it's perfect.
Not like PewDiePie. What do people watch nowadays?
I don't know, man.
Mr. Beast. Mr. Beast.
Okay. Then the model will be creating explosions or whatever. So it should work still. Yeah, but I do think YouTube is very good. I think YouTube data is awesome. It is probably like, I don't know, if I'm looking at data that I can find on Reddit versus YouTube, I somehow think maybe YouTube is a bit higher quality. At least like someone still, like if you're looking YouTube for, I don't know, not like doctors that have created YouTube channels or stuff like that. They have at least put effort into making the video, making it cohesive.
There's
and
more
nice
dialogue, I guess. Like that, the text from videos is more dialogue driven, and it's very different to how you write actually on Reddit.
Yeah, in fact, podcasts would be perfect. Every podcast would be perfect because it is exactly this. Train the model to hold a conversation.
So yeah, one thing we always talk about in Dev and Doc is how we reach this holy grail of a healthcare large language model that's domain specific and aligned with clinicians. And we always talk about one of those steps is taking a step away from instruction tuning on question and answering pairs, which is what so far all of the LLMs have been using.
Yes, and just to prove why in fact that can be problematic. Sorry to interrupt here. I just wanted to come back to, like, I was recently training a new model. So, you know, like before we talked about foresight, which is a model that is capable of predicting the patient's future. And you take the patient timeline, what was happening with them, and then you predict what will happen with them in the future.
And that made a lot of noise. So have a read, by the way. That was published in Lancet Digital Health, and some news, a lot of news organizations followed that up as well. So it's
I think it was nice.
It's nice.
But I was recently training foresight too. And what we are trying there is a very similar thing, but we are still taking the patient timeline, what was happening, all the medical history, and we break it at some point and then try to predict what is this patient at risk for in the next month, for example. Because if you can predict that, you can prevent like an early discharge, or you can, so this is for inpatients, patients that are already in hospitals. We want to predict.
Is there something, complications and readmissions and
exactly, or something really serious that we should be careful for and all of that. And we trained our model and we then compared it to a couple. So we compared it to this GPT-4 and basically any other open source available biomedical LLM, like BioMistral, or even this new one that came out and all of that.
Very nice.
And it still proves how important the hospital data is. Because our model that was trained on hospital data, it was even a small data set. It was, I think, in total maybe 30,000 patients, which is
in
not
the grand scheme of things.
Exactly in the grand scheme, but still 30,000 patients is a lot. And with our model, we are achieving around 90% accuracy on being it's not accuracy, it's precision. 90% precision, being able to predict what diseases this patient is at risk for correctly. And other models, even GPT-4, is only around 60.
Wow,
so that's like a giant leap between 60 and 90.
Yeah.
And most other open source models that were trained on these question answering tasks are even worse than GPT-4, so around 40% or something like that. So it just proves that, sure, it has done awesomely well on the medical question answering, but maybe that doesn't
It's not reflective
translate.
of the real world. Yeah.
Exactly. The health data is extremely messy. You cannot really just translate what you learned in a question answer pair that is perfect to taking 100 documents of patients' medical history and then predicting what they are at risk for in the next month.
Yeah. Yeah, I mean, we always talk about this, like the quality of data. And that's why it's so hard to get a really great healthcare model at the task of predicting diseases and prognosis and complications, right? Because that data is not on the internet.
Yeah, exactly.
You need to delve into the real world data for that.
Yeah, and even just using the real world directly is not really an option. You have to clean it, you have to structure it, organize it, make it into something that is from which the model can learn.
Yeah.
I still remember the first time I tried training the GPT model on just pure health data, like pure hospital records.
Yeah.
It was a complete
It was
mess.
a mess. It just generates gibberish.
Yeah,
right?
exactly. Because it was like, oh, the patient came in because a car hit him. I was like, okay, I don't know, maybe we want to, it is a possibility, but that is not the task we want the model to solve. So it's like you have to align it a bit to your preferences and really the use cases that are useful for you.
And that's step one, the data for the foundational model. But then, as I was talking about the instruction tuning, the second step, all of these, so far the big popular models are taking question and answering pairs, which the model then learns, if someone gives this task or this question, I'll give this kind of response. But in healthcare, especially if you want something to take a good history or understand how to communicate with patients, you need to take the conversation. Like it's not enough to just have question answering. It needs to be a kind of multi-step conversation, or multi-turn now they call it. But not many people have achieved that. It's very difficult, right? Because we don't have many recordings of patient conversations.
Yeah, we have that rarely. Yeah, I agree.
But this will obviously change. Yeah, I think. Well, yeah, I think if the ambient clinical documentation explodes, which is taking off, if you actually record the real-time conversation, that will be a crazy data set.
I agree. I think we have that already, but maybe more on the mental health area. I think in physical health you don't really have that.
Yeah.
But I do know even here in South London and Motley, a hospital I'm part of, we have some recordings between a psychiatrist and the patient.
Okay, that's very nice.
So that is like there, I think we have a very good data set. But yeah, as you said, in physical health, I think we don't really do the recordings between patients and doctors. So yeah, no one is doing this, or very few people are doing this.
Yes, which leads us very nicely on to the second part of our conversation, which is I wanted to talk about Hippocratic AI and the large language model they've been building. We're maybe a few weeks late to the game. The paper was published a couple of weeks ago, and I've seen there has been discourse online, but haven't seen many people really dive deeply into it as much. But yeah, I don't know if you've read the paper, but I'm just going to give you a quick brief. So
I have some beef with them a bit. But
beef?
Yeah.
What did you interview them?
No. I applied for because on their website you can apply to access their models and test them and all of that. But they said, we don't really care about academia. We are focused on industry. So I was not too happy about that. But okay.
Those snobs.
Yeah.
They've made something quite nice. You know, we always talk about on this podcast, how do you make an LLM that's useful for healthcare? And, you know, one drawback was the cost, right?
Yeah.
Because there are many steps we talk about in our LLM introduction episode about how to actually make in a large language model. One drawback is the cost.
Yeah.
We talked about, yes, let's start from the first step, like Llama 2, Llama 3, everything. Yes, the quality of the data is very important, as we've alluded to. But how do you get healthcare data into that? And like you said, how do you get useful healthcare data, like hospital data or conversations or history taking? That's very hard. So one thing that I heard they did, and they talk about this in the paper, is they apparently trained the model from scratch, which is very nice, and that would cost a hell of a lot, right?
Yeah, exactly. I think Meta with Llama 2, I don't know how much they spent with 3, was like 10 to 15 million just to train that foundation model.
Yeah. The company is worth a lot, and they've recently raised 50 million in Series A funding. So, and then they're partnering with NVIDIA. So anyway, from what I heard, they've taken proprietary data, but they also do disclose that they took data from like medication data, prescription data. Really interesting, they took malpractice, like insurance data from the US.
That makes sense, yeah.
But that's very interesting, because I heard the CEO talk, and he was saying that, they want to know like where problems arise.
Yeah.
And that's a very good source of problems. So it's very interesting.
That's an awesome idea, yeah, exactly. You want always to show also the model, to train it on something that is wrong.
Yeah.
So that when a model is encountering a new situation or something wrong that is happening, it knows how to deal with that, and not just like, oh, something is wrong and I have no idea what to do now because I never saw that. I was trained on perfect, correct data.
Yeah, exactly.
So yeah, that's very important.
And a big part of the web that normal language models scrape from is the common crawl.
Yeah.
I think there's a lot of discourse about how good that data is, and there was talk about whether a lot of healthcare data is included in that or not. But anyway, they handpicked a lot of nice data, it sounds like.
Yeah, I still think they used common crawl.
Probably.
It doesn't, like, where else can you find a big data set to train a 100 billion parameter model?
Yeah, or maybe they kind of took it and then refined it. I
for sure.
I've heard the CEO talk, and he said common crawl is not good enough, and it doesn't have access to a lot of the PDFs, which sits where lots of healthcare information sits.
Yeah, I agree with that. I agree.
So they do that, get a nice kind of foundation, good high quality data, and then the next step we talk about is the instruction tuning. And like we just said, question and answering pairs are not good enough.
Yeah.
And all credit to them, they've taken it to to the real level. They took simulated conversations between clinicians and kind of not real patients, but like simulated people. I guess they're actors who are very used to pretending to be patients. So we do this in med school, right? Before we get to speak to real patients, I've talked to so many like actor patients.
Yeah, makes sense.
And to be fair, they're very realistic actually.
Yeah.
Some of them are very convincing. And I still remember in med school, I used to have to deal with like, they give you angry patient scenarios. But actor, no matter what you say, the actor will just get more and more angry at you. And you need to try and de-escalate. And that was actually quite useful for...
I think that makes sense. I think that makes perfect sense. They used real people.
Yes.
I'm also really interested, could you just do that with language models? Have them simulate...
Synthetic,
Yeah, completely like simulated patients via language models. But
I did think that. Yeah. But I don't think it would be as realistic, because I have got ChatGPT or GPT-4 to simulate conversations and dialogues before. It's not as realistic.
Yeah. But it can, I don't know, it can maybe be a base layer on which you can build with real people. So. Yeah, sorry.
No, I think that's a great thought. And one good thing they did was they also, I think this is the step after, but in the kind of further fine-tuning, they got the actors to take tangential, take the conversation on tangents, just like what happens naturally, I guess.
Yeah.
And then got the nurses to guide the patients back to the conversation at hand.
You know what I'm always thinking there? I think like that is a great idea. I'm thinking when they are exploring those scenarios, is that the only one, or did they cover all of them? Because I think like there is whenever I'm making a synthetic or simulated data set, I think like, how do I cover all the use
All the
cases?
bases, yeah.
Because sure, tangential things that happen during conversation, like this one, it is possible. But like, how do you cover all the other possible, like, oh, a light broke, or like a million, or the electricity went out, or like, how do you do, or my EHR system is now not working and I don't know what's happening with you, or the patient is not really speaking English.
Yeah.
Like there is a million of
things
these.
that could go
How
wrong,
do you
right?
cover all, and did they cover all of them?
Yeah, well,
because I didn't see.
know.
I read a bit the paper, so I didn't go through all of it, but it's a giant paper.
It's a giant paper.
Yeah. But did they cover all of these use cases? And this is like the main thing why I wanted access to the models. I wanted to see, like,
red team it.
Did you really think about?
I would love to check as well. And you know, that was my first thought. I was like, how do they know between a like worried, like distracted person versus someone who's delirious or even psychotic?
Exactly.
What happens if you call someone and you're like, hey, how are you today? How's your diabetes? And they say, oh, there's police chasing me down, and like my neighbor's trying to kill me.
Yeah, what do you do in those cases? Is the AI then approaching that the right way, or does it know how to deal with that?
So
it doesn't know.
There is a bit of So that was one of my thoughts, and also. Do you just bury it? Is it better to like guide it back to the conversation, or is it better to just have a hard barrier that you then put on top and say, oh, this is not something we should be talking about. Let's, if you're worried, call 999. If not, let's just go back to the conversation.
No, exactly that. I think it is like, I just want to see how did they solve it.
Yeah.
How did they solve the million different scenarios you have when a doctor and a patient talk?
Yeah.
They mentioned a couple, but they didn't really mention how did they say all the possible things. And still, a simulated patient can only do that much, even if they are an actor. Yeah. They can do. But
there must be just like how emergent capabilities come. Like, surely that there is a point where you give enough examples. They kind of.
Oh, you think it doesn't need.
The model it doesn't. You don't have to cover every single scenario. Probably after a while, you probably can generalize.
Yeah, that's possible. This would be an interesting research area to see how many of these do we need until the model can. Yeah. Okay. Let's go back to
look. So step one, get nice data, foundational model. Step two, instruction tuning, and further kind of agentic fine tuning with simulated conversation. Yes. Very nice. Yeah. And then I think they did some more kind of reinforcement learning on top to make it even nicer. But what they were quite clear about is they did not want to focus on the high risk stuff. So nothing about like diagnosis, risk prediction, all this stuff. They want a virtual back office in the hospital. Okay.
That makes sense. Yeah.
And we always talk about that's the first thing we should go for. Just administrative tasks. Just get those done.
But did they go for administrative, or do they go for more like when you? Maybe we should just explain what is administrative. When you tell me administrative, I usually think about people typing and people doing invoices and people doing like stuff that is, administrative in general industry. So what do you mean here by?
Yeah, okay, very good. Yeah, so not as much that kind of administrative, but administrative for the clinicians. So kind of low scale tasks that we do day to day that take up a lot of time. So for example, one example they used a lot is chronic, like heart failure nurse. Okay, and a bit of historic background, I guess. Before there were specialized nurses, I guess doctors used to have to deal with a lot of follow-up conversations for relatively simple ailments. Yeah, and that we still do those, but I guess a lot of those tasks have recently, in the last couple of decades, been done by specialized nurses because they have great clinical acumen, they know patients well, and they're completely skilled enough to do those conversations. So for example, it is kind of checklist-esque. Like if you wanted to follow up a heart failure patient, there's certain things you want to ask, like, oh, how's your weight today? If you have heart failure, you basically lose the ability to kind of sometimes clear water from your body because your heart's not pumping as well. So you want to know, like, how's their weight today? We encourage them to weigh themselves on a daily basis. Okay. How much water are you drinking?
Okay.
It's just an equation. You want to lose as much water as you're gaining. You definitely don't want to be drinking more fluids than you're losing. So are you peeing enough, right?
But is this in hospital or is this out of the hospital?
This is out of hospital.
Okay.
So after someone's been treated and discharged,
Yeah.
you do a quick follow-up.
Okay, so this is just like basically follow-ups for special conditions. If you have this condition,
specific.
we have a follow-up and we know what needs to be checked, we
Yeah.
know what needs to be done.
And relatively low risk, right? So if the answer to any of those questions is no, I'm struggling, or oh no, I've been getting, then it probably you can route it to a nurse or a doctor.
Okay.
So that's a nice use case. So they've assembled like an MDT group of people. So like nurses, specialist nurses, dietitians, nutritionists, social workers.
Yeah.
And they even said it can do simple things like arranging discharge. So for example, if a patient's ready to leave the hospital, right? Or a patient wants to come to hospital for a clinic appointment, you won't believe how much time is wasted on booking a transport home.
Yeah.
Like honestly,
I would believe, to be honest, it's not strange.
I mean, you have to call, a nurse would have to call the taxi, they'd be like, oh, can you pick this patient up? And then go back to the taxi, go back to the patient, is this time okay? And then go back to, that can take like half an hour. So the great thing about this, and I heard them talking about this, is it can simultaneously coordinate these kind of things. This is not even clinical, right?
No, exactly. What I'm just thinking is like, GPT-4 can do this.
Yeah.
This is not really going into, there is no risk for anything. I think a lot of these tasks and whatever GPT-4 can do. And what I'm usually like, what I think is the hard part is now integrating these into hospitals.
Yes.
It is not really the hard part, like making the models, sure, but integrating into the hospitals is where the trick comes.
It's much easier to I'm sure we can make one that can order takeaway for us.
Yes, easy. Yeah,
easy. Yeah, just an app. Just like get me a pizza and Pizza Hut deliver it in 20 minutes time. Do you think that they can do that now?
I think
it calls Pizza Hut with a synthetic voice, gives you bank details.
100%. Yeah. I mean, like we could make such a model with Llama3 by tomorrow. If we wanted. So it would just be some small model, calls up everyone.
That's a business idea. Look, I'm a doctor, I'm hungry during these night shifts. I don't have time to order takeaway, but if you can coordinate that and speak to the driver, be like, oh, just leave it in the doctor's mess, I'll come and grab the food after.
See, but that is, I think that part is the easy part. And the same thing is with that ordering of transportation. And I even think these tasks, which are the follow-ups for heart failure. I even think that is like, you said it looks like a checklist.
Yeah.
So you basically just want to write down a couple of those, put it into ChatGPT, say like, if the patient is all well and everything is fine with these 10 questions, all good. Yeah. If anything is a bit out of the box, notify the GP.
I think you raise a good point. Like, yes, GPT-4 Llama, they can do all this, but at the back of your head, you're also worrying whether the data is good enough, whether they can pull the conversation back, and also how do you evaluate it. I think it all comes down to evaluation now.
Yeah,
we have a lot of benchmarks based on exams, and we talk about this all the time. Like exams are not the same as clinical practice, and how do you evaluate this? So why don't I talk a bit about how they evaluated this?
Yeah.
So actually, I'm just going to bring up my laptop because I want to get this right, but it's one of the biggest kind of manual evaluations I've seen of any healthcare LLMs to date.
Yeah.
They recruited 1,100 US licensed nurses and 130 US licensed physicians to evaluate the model. And so one of the first things they did was they compared each of their mini kind of specialist agents compared to GPT-4, compared to Llama 270B, and compared to nurses. So their model is called Polaris, in case I haven't said already. But so here we can see one useful thing they want to evaluate is whether Polaris model can detect kind of drug toxicities from conversations with patients, any like drug misidentifications, prescription adherence. So basically, I guess just calling the patient, asking, are you taking your medication? What symptoms are you getting? Could this be a problem with the medication? And you can see here, it's kind of outperforming. So for prescription adherence is on 94%.
Yeah.
basically better than nurses, which are 92%, and better than Llama 2, 70B at 72%, but actually a bit worse than GPT-4. GPT-4 is 97%.
Wait, but when you say medication adherence, what does that, what was the model used for? To call up the patient and just get a checklist of...
Exactly, and see if they're taking the meds.
Ah, okay.
The one thing I didn't mention was they use a constellation kind of approach, right? So they say, combined over 1 trillion parameters. But basically they have a mix of kind of medium and large size models. So they have like a small model who then talks to like a bigger model, a medium size, like 70 billion model. So it's kind of interesting because the architecture, then you have like several checkpoints and you have like different specialists, just like how it is in the hospital actually, right?
Yeah, makes sense.
You know, we can't be experts in everything, so it makes sense to kind of fine-tune different silos of like intelligence and domain specific knowledge. They got the nurses to role play as patients and the physicians to role play as patients, and then they got the model to basically call them up and speak to them. The thing they showed us the Venn diagram, which we can put a picture of, but it's basically nurses rated by nurses, and then Polaris rated by nurses, and Polaris rated by physicians. Does that make sense? So they either got a nurse to call a nurse, or Polaris to call a nurse, or Polaris to call a doctor. And this is kind of crazy stats, but I'm just going to go through the main things. They said bedside manner was one of the first things they asked for. So the questions are, do you feel like the nurse/AI listened to you? Do you feel like the nurse/AI cared about you? Do you feel comfortable in confiding in the nurse/AI? And did the nurse/AI get to know you as a person? These are the questions about bedside. I don't know if those are the exact questions I'd ask about bedside manner, but anyway, Polaris did better than everyone else apparently. So long story short, Polaris was the highest rated by a couple of percent, more than nurses by nurses. Okay.
So it basically means like Polaris is better than a nurse rated by a nurse.
In bedside manner, yeah. Which is kind of crazy, but I can see here if you break down the metrics, the reason Polaris is better is because of that last question. Did the nurse/AI get to know you as a person? I don't know if that's like a key component of a bedside manner.
I just think I always think that it is normal that AI models will be better at this to some extent, because the AI model can remember everyone.
Yeah.
If an AI model if a patient tells something to the model, that is recorded and there is no way it will forget that. There is no way to come tomorrow and feel like the model didn't listen to you because it knows everything.
Yes.
You can feel that with a doctor, because sometimes I come the next day to the GP or to the doctor and they're like, oh, what did you say yesterday? I'm like, did you even listen? What did I say yesterday?
Yes.
It makes no sense, but an AI will never have that.
Yeah. People get distracted. And time is a problem as well. So AI has unlimited time to chat to you, I guess.
Yeah, exactly. But that also makes sense. I think for those use cases, it makes sense to use an AI.
So basically, they really liked the other domains, which are conversation quality. So would you pick up the call again from the nurse/AI? The AI was very comparable. Was it as effective? People rated yes, it's just as effective. Now, the interesting one here is medical safety, okay? So this domain is asking, the nurse/AI provided medical advice that may result in ... So nothing incorrect, no harm, minor harm, severe harm, or death. So what kind of bad advice they've given basically is asking, right? So nothing incorrect would be ideal, and then death is obviously not ideal.
Patient died.
Yeah, and then in between is also not very ideal. So amazingly, right, the AI scored 97% basically, rounded up, on nothing incorrect. So 97% of the time it doesn't get anything medical safety wrong. Whereas nurses was only 81%, nothing incorrect.
I think this makes sense. I don't know. I always feel like when people are telling me AI it is bad to be used in healthcare because there are many risks, and I think it will be really what's shown here more careful
Yes.
than people.
And because it's time, I think a lot of this is time, but also because they know a hell of a lot more than we do. But you know, the physicians were 96%. You know, only 1% shy of Polaris. So,
where was the other 3% in Polaris?
So no harm or minor harm is where most of the other stuff lie, which is not surprising.
Yeah.
Look, the good thing I want to say is neither the nurses by nurses or Polaris by nurses or doctors got anything that resulted in death. Okay, so that's the good thing. So,
yeah, that should be normal. I don't. If we saw something there, I would be very worried.
Hey, look, you know.
I don't know.
Yeah.
No, but I think like what this evaluation that they have done is awesome.
Yes.
I think this is great. It just tells you that the AI models have a place and that there are tasks for which we can use them, and that we are maybe to some extent even doubting them a bit too much. We are overly cautious and like, oh, we should never use them for these because they will recommend someone to take a medication they shouldn't. As it turns out, they will not do that.
Yeah.
Or they will extremely rarely do something
yeah.
like
So
that.
here the Polaris for severe harm, so the one before death, which I think is quite important, is 0.15% when rated by doctors and 0.04% when rated by nurses. So that also goes into the evaluation.
Yeah.
Who's evaluating it matters, right?
Yeah, of course.
Because the doctor the physician here thinks there's a higher rate of severe harm here than the nurses thought. But it depends on the scenario as well. But nurses didn't get anything severe harm or anything in death, which is very nice, I think.
No, but that is perfect. But also, even when we are talking about these models, we are never saying they should directly interact with the patient and give a medication to the patient. That will, of course, be validated by a clinician, by a GP, by whoever.
Yep.
So like even that small percent that there is a possibility for danger, you will still have a verification on top and make sure that it doesn't happen.
Yeah. Yeah. Look, I think it's very promising, and it's no surprise that NVIDIA was really kind of using this, advertising this as well, saying how useful this could be in the future.
No, I agree. I think the biggest really benefit that these guys have done is the validation, the evaluation and the validation. The stuff before, sure, it is nice, but the approach of take some nice data, do instruction tuning, then do RLHF, that is the standard approach everyone is using. They've adapted that to healthcare, which is awesome.
Yes.
But the best thing ever is really getting 1,000 nurses, whatever, hundreds of doctors.
Yeah, is great.
To validate that and to prove what is possible. And again, to use that data you have just created for further fine-tuning and training of the models.
Hopefully we've talked a lot about the new Meta Llama3 and also the amazing healthcare model from Hippocratic AI. And more to come.
Yeah, thank you very much for listening, and we'll see you next time. Bye-bye.
See you. Bye.